Hello, it's Scott Manley here with episode 88 of Interstellar Quest. We have Gilmore Kerman and Admin Kerman heading off to the runaway remains of the Duna Express, with, of course, Archibald Kerman on board on a one-way ticket around the sun for a very, very long time. Thankfully, they have a nuclear fusion-powered spacecraft and they're trying to intercept. So yeah, it's a standard intercept operation. We've set it up as target, and what we do, of course, is we burn offset to the velocity vector to essentially push the retrograde vector towards the pink retrograde marker, which is ideal. I mean, it basically puts us there slowly, gets us closer and closer as we move in here. This is at 12 times regular speed, so you don't have to sit through all the very slow approach. We initially were moving in at several kilometers per second, but as we approach, we slow down, get our velocity lower and lower, so that when we get there, we're not having to fly by it at several kilometers per second and potentially fly past and miss, because that would be pretty embarrassing if our approach plan actually overshot, wouldn't it? You'll notice that much of the time I'm only using about 30% thrust to maximize my specific impulse. Now we're within 100 kilometers, I turn on the display and there it is. We're heading straight for it at about 200 meters per second. We'll slow down a little more before coming up alongside it, arresting our velocity, and hopefully being able to stop, dock, rescue and return. That is what these guys' jobs are. They are, of course, flying the pinnacle of Kerbal technology, a fusion power plant generating gigawatts of power, which is in turn powering a fusion engine, a deuterium-tritium fusion engine, which is very efficient. But as old me is about to find out, it has one drawback. And we get a little pause as it loads the map, and there we go! We have arrived in the vicinity. Oh! Engines throttled down as they present a radiation hazard. Oh yes, that was something I forgot. I'm travelling at 70 meters per second, and I hope I don't hit it because I can't fire those engines without irradiating the occupants of the Duna Express. And we're okay. Whew. That would be unfortunate. Of course, I could have just cheated by time accelerating, couldn't I? But I guess we'll have to wait until it goes out of range and turn around. Yes, as you've probably heard a dozen times before, deuterium-tritium fusion generates neutrons, and neutrons are not very kind to organic flesh. They're also a signature of whether you have an actual fusion reaction going on. If you remember the occasional claims of cold fusion, most of the time there are no neutrons being generated, and that's a sure sign that it isn't actually generating power by fusion. So yeah, you see how I managed to mess up again. I'm trying to turn around and get docked by using reaction control thrusters, and by an accident I managed to time accelerate past it, so I zipped the other way, and well, eventually I'm going to get myself into position. Yeah, neutron radiation is kind of like the worst case scenario generally for radiation, because neutrons are pretty heavy, and because they are neutral, they are very penetrating. They travel through a lot of material before they hit something, so you can't block them as easily as, say, beta radiation or gamma radiation or indeed alpha radiation. You know, there's a classic, I don't know, it's a classic test or whatever, a classic quiz that I've heard from nuclear engineers, and it's like, you have 4 cookies, one's an alpha emitter, one is a beta emitter, one is a gamma emitter, and the other's a neutron emitter, and you have to throw one away, hold one in your hand, put one in your pocket, and eat one. Well, what you do is you throw away the neutron emitter, you eat the gamma emitter, you put the beta emitter in your pocket, and you hold the alpha emitter in your hand. But we don't need to worry about that, because Gilmore and Admin Kerman have finally completed their voyage. They're here, and they only took 1 day and 16 hours, which is pretty darn impressive. I mean, sure, Archibald was expecting to be home by now, but he's only being delayed by a few days. Anyway, we'll bring him around and take him in We, of course, are still running the older version of Kerbal Space Program, so we can't just right-click and transfer the Kerbals over. Let's get him in here. Onto the ladder. He's going to say hi. No, he's not going to say a hi. He's going to suffer from space drunkenness. He's clearly spent too much time in space. Okay, Archibald, you are supposed to be a Kerbal. It's a good thing there is no cameras on this, because it would be pretty embarrassing. Okay, let's try grabbing this. That is pretty impressive, I have to say. I did not entirely expect you to not fall off the ladder. I didn't expect you to fall quite that far off the ladder. Okay, let's adjust the camera angle and one more time. Third time is a charm, so they say. But honestly, I think Archibald is hoping the third time is some fresh food, since everything in his stores is almost a year old. Ah, there we go. Let's undock. And we are now free to return home, and of course free to start using our engine once again. This nuclear engine, the radiation does not affect us, even although it is part of the same spacecraft. It's only if you're in a spacecraft nearby and somebody's firing a fusion engine, in which case the radiation will penetrate through your cabin and kill you. Of course, assuming we knew the kind of radiation tolerances of Kerbals, we could actually calculate these things correctly. I mean, after all, it is just a case of, you know, drawing lines and calculating shielding. There's nothing that's not impossible here. But I would suspect that for most spacecraft, the biggest radiation problems will come simply from being in space for a really long time. That's one of the things they're going to be checking with the Orion spacecraft, the Orion test that they're flying in December. They're going to have a whole bunch of biometric stuff on board to test like radiation levels, temperatures, all these things to make sure that the cabin doesn't go beyond any habitability constraints that would otherwise, they would otherwise need, because you don't want to have a spacecraft which flies perfectly but kills its occupants. Anyway, to get back, we pretty much just target Kerbin and then accelerate towards it. It says 4 days out, so time is coming down. You can see our close approach is shrinking. So I'm trying to guess which direction. You see me adjusting slightly off the nav ball to accelerate my descent. Try and get it relatively close. 20,000 kilometers seems like a good plan. That's inside the orbit of Minmus. And so from here, where we're going to see this, there it is. You can see it flying past, and we're going to fly over the top of the system. So now what we want to do is bring the capsule back. And ideally, we want to, well, first of all, we obviously want it to scrape through the atmosphere and slow down. This has a proper heat shield on it, so we can go at quite high velocities. We're moving at 3 kilometers per second. By the time we get down there, I won't be surprised if we've risen to maybe 3.5 kilometers per second, but we won't go that much faster. But what we want to do is put the spacecraft near to the Kerbal Space Center. So once we get a periapse inside the atmosphere, we want to account for the rotation of Kerbin. Now I can eyeball the location of the Space Center and say that that's roughly 90 degrees away from the vector where I'm coming down. So it says 6 hours or thereabouts, right? So I actually want to slow down. It says 6.5 hours. I want this to be nearer 7.5 hours, so it does one complete rotation and 1/4 of a rotation, and that should put the capsule on an encounter trajectory which is pretty close to the Space Center. So there, time to periapse, we want 7:30. So I also want the periapse height to be not so low that we go through the atmosphere too quickly. So it's a little bit of tweaking here. And there we go, 7.5 hours, 28 kilometers. That is a pretty good descent trajectory. So now we have our entry vector figured out. We're going to accelerate down. And well, we can actually ditch the whole spacecraft. Although this is a nuclear power plant, it is a fission nuclear power plant. And generally those things don't get horrifically radioactive. And it's certainly, given that it's only been in space for 4 days, the radioactive aging due to the neutron flux coming out of there probably isn't going to be too bad. So yeah, let's just take a pause to look at the beautiful aurora around the North Pole of Kerbal. I turned the entire spacecraft around just so I could look at this. It's so darn pretty. Of course, we're going to have to flip the spacecraft back before we actually enter the atmosphere. That would be pretty bad if we didn't do that. But yeah, we have a nice heat shield on here, and that should protect the spacecraft a little better. And I'm hoping it will actually protect those radially mounted parachutes. I think that's the way it's supposed to work, that radially mounted objects get insulation as well. Now, of course, I'm coming in at 4 kilometers per second. I'm wondering whether I have gone deep enough into the atmosphere, of course, right? There's the classic problem. If you go too deep, you burn up. If you don't go deep enough, then you skip off back into space. And by the time you come back around, everyone on board is dead. But it looks like I picked a good altitude. The heat shield is in fact working, and Gilmore, Admin, and Archibald are gonna touch down in the sea. They're gonna splash down into the sea a little way north of the Kerbal Space Center. Now you notice that I'm deliberately pushing the angle of the capsule slightly off from my velocity vector. That's actually taking advantage of the bottom of the aircraft, or the capsule, sorry, to give me a little bit of more lateral velocity, pushing me southwards ever closer to the space center. So you can see that even there, I still had some velocity slowing, or some lateral velocity. But now we touch down! Victory! That's Gilmore, Admin, and Archibald landing near the Space Center with a precious cargo of science. 2,390 science, all collected from Duna and its tiny moon of Ike. There is no doubt the secret, perhaps some clues to what Lanber was doing and why he was there. Meanwhile, also in deep space, arriving back, we have Albus Kerman and, of course, the Eve Explorer, and it's going to be making its final course correction to put itself on an encounter with Kerbal. Now, originally when I launched this, I was figuring that I would recover it and repurpose the spacecraft since, you know, technology is good, it seems a shame to waste it, but as it turns out, it's been so utterly superseded that it might be a good idea just to ditch the whole thing. So we have, Durdos, Albus, and Sonson Kerman all coming back from Eve at a much lower relative velocity, thankfully. Also coming over the North Pole, and also we're going to make some adjustments to put it near the Space Center. This time we're a little closer, and our periaps is also lower, so we have to basically raise our periaps and make the time to periaps probably around 12 hours and 20 minutes. So to do that, we're going to have to, retro burn just a bit, and this thing, of course, turns relatively slowly considering that it's essentially a giant self-sufficient spacecraft which has gone all the way to Eve and back. Also, we have to be much more careful with our entry here, because this capsule, if you remember, I didn't fit it with the heat shield. I just used it in the top of the spacecraft, and I figured that I would be able to ditch the rest if necessary, but it doesn't have a heat shield, so it can't arrive at interplanetary velocities. So once we've adjusted our orbit, we're hopefully going to dip down and then use the engines to further slow the spacecraft to make sure that we actually fly near the target and slow down enough that we can successfully re-enter the atmosphere without burning up our ship or our parachutes or anything else that we actually need to provide a safe landing for our Kerbals. Ah, there we go. We now have a periaps which is not 0, and our time to periaps is about 12 hours 20 minutes. We are on course. Now we need to make some course corrections just to try and start slowing ourselves down. Now, I'm not sure how much fuel we're going to get from this thing, and it seems that we're about to run out of fuel in that central engine. If you remember, there we go, no fuel left on that central engine, so I'm going to need to figure out how to pump fuel around. Oh yeah, I do have TAC fuel balancer, that should actually help. Ideally, we want to burn as much fuel as possible near to the planet, because the deeper down we are in the gravity well, the more efficiency we get, the better, the more effect that delta V is going to have because of the good old Oberth effect. Okay, let's start transferring fuel around and keep that balanced. So I've got to kind of just balance my velocity vector. So I don't want the periaps to drop too much. So I'm going to try and keep that around 30 kilometers. And at the same time, I'm going to try and slow my descent. I'm guessing it says 3.5 minutes to periaps. So hopefully I'll burn through all my fuel before then. Although maybe we'll slow down enough that my time to periaps will start increasing. Point is, we don't want to be arriving inside the atmosphere at the kind of velocities that this thing has been used to. Okay, there we go. Down to 2.8, 2.7, 2.75. Slowing down. And my periaps is a little high. Again, we have the danger that we will skip through the atmosphere completely and come around. If that's the case, actually, we will just make sure that we're not going to ditch the rest of the spacecraft until we're absolutely sure. I could probably aerobrake the whole thing several times, but I have more or less lined up an encounter with the Space Center. And I think, actually, it will be coming up on the left there in a couple of, maybe a minute or so. We'll see it because of all the stuff sitting around it. So I'm actually deflecting my trajectory towards it in the hope that I might pass a little closer. The spacecraft's velocity is down to about 2.3 kilometers per second, and we're about to run out of fuel. Just in time. Now we're going to undock the spacecraft to make sure it's disposed of correctly. As in, we don't want to know where those pieces land together. The lab section is getting dumped in one go, and the drive section, well, hopefully it'll end up in the ocean. Meanwhile, these guys, they have to hope that they get through the atmosphere safely. As I said, they have no heat shield on this. I hadn't really thought about that until I planned the descent, and then I thought, oh wait, I don't really have a heat shield. Ah, there's a space center there. Look how close I was able to put this thing. Unfortunately, I'm going too high and too fast. So at most, I can just wave at them as I fly past. They'll be able to see me from the ground. Even better if they have infrared telescopes. They'll be able to see the familiar thermal signature of a spacecraft zipping through the atmosphere, compressing the air in front of it and generating heat. So you'll notice here again I'm using the lifting effect of the capsule. I'm trying to angle this to make sure my altitude or my descent rate is minimized. So my vertical speed is about 90 something, 94, and I want to stop that growing too quickly, because if it grows too quickly, then that's a sign that I'm essentially falling through the atmosphere faster than I would like. When you don't have a heat shield, it's much harder to strike that magic balance between altitude and everything. The window of entry, let's say, through which this capsule can descend is pretty narrow, and we're starting to get some overheating on those parachutes. And unfortunately, without those parachutes, we will be dead. I don't think there's any way for us to survive if that's the case. Okay, so now we're down to just under 2 kilometers per second. Thermal problems on those parachutes. Those things are heating up, but we are slowing down at over 1 G, so hopefully we are going to get through this. I can start to see some flames there. Temperature is 950 centigrade and rising very, very slowly, but it looks like it's going... Oh, it looks like my velocity is going down faster than my temperature is going up. So I think we may have peaked out here. And this may be a good sign. Yes, I can see the temperature dropping. Overheat is dropping. And so now I'm really just wanting to let the thing slow down as much as possible. We're down to 1500 meters per second. We have flown a long way past the space center, but at the very least we are not anywhere near that mystery space center that was found on the other side of the planet. Who knows what secrets it holds? Well, Lanber found something out, obviously. And we have a clean parachute deployment, and the crew is heading to the surface underneath those giant canopies, slowing their velocity to 12 meters per second, and a clean touchdown in the ocean. A nice recovery considering the constraints I had to work with. I'm sure this is some fascinating scientific data which will no doubt enrich our space program. What do we get? It says 1,769 science put towards the warp drive, which I hope we will see in the future. Until then, I'm Scott Manley. Fly safe.